This video explores the topic of Industry 4.0 within the framework of the European project titled Personalized Education in Measurement Science and Technology, Empowered by Machine Learning. Throughout our history, we went through different industrial revolutions. The first one was associated with the introduction of steam power and the first mechanical loom in 1784. The second industrial revolution is related to the introduction of electrical energy and the development of the first assembly line in Cincinnati in 1870. The work was divided into different subtasks accomplished by different workers. The third industrial revolution is related to the introduction of electronics and IT systems into industry. One iconic event associated with this revolution is the use of the first programmable logic controller in 1969. Finally, the fourth industrial revolution started in the early 2010s. This revolution is associated with the use of cyber-physical systems. But what is Industry 4.0? Industry 4.0 is the improvement of the traditional industry by means of the introduction of the so-called smart technologies. Smart technologies include IoT, AI, big data, robotics, cloud computing, digital twins, and augmented reality or virtual reality. The aim of this new approach is to improve the working conditions, the productivity, the production quality, and in general, the quality of plants and processes. What are the reasons for defining this new paradigm? First of all, the need to reduce the time to market. Consumers always request something new in a short time span. There is a need for continuous innovation, and this cannot be done with the traditional approach of production and design. Traditionally, the big competitor has beaten the small one, but now the fast one is beating the slow one. The market requested personalized products, but at the prices of mass-produced goods. To satisfy effectively, the production process and plant must be enhanced and become very flexible. The fact needs to be able to change all the details according to the requirements and adapt quickly. Nowadays, customers openly share their experiences online, rewarding good and criticizing poor product quality. To meet consumers' expectations, companies are adopting smart, closed-loop quality systems that monitor every production stage in real time. This not only ensures high product quality, but also provides full traceability and compliance with legal standards. Industry 4.0 focuses on improving energy efficiency across all stages of production. It is not just about making sustainable products anymore. The entire manufacturing process must also be environmentally friendly. By adopting smart technologies and data-driven systems, companies can reduce energy waste, lower costs, and gain a strong competitive edge in the global market. The initial effort to define the design principles for the Industry 4.0 framework was introduced through this research. The principles include technical assistance, interconnection, information transparency, and decentralized decisions. The focus is on enhancing collaboration, standardization, and security across industrial systems. Technical assistance supports both physical and virtual operations, while interconnection enables smooth communication among all industry components. Information transparency improves data analytics and decision-making efficiency. Decentralized decisions promote flexibility and faster response in production. However, handling huge data remains a key challenge for implementing these principles effectively. The implementation of Industry 4.0 can be achieved through the introduction of enabling technologies. Many of these technologies are based on existing concepts that were previously known but not applied in production due to technical limitations. With advancements in technology, these concepts can now be effectively integrated into industrial systems to enhance efficiency and innovation. The key enabling technologies of Industry 4.0 include big data, Internet of Things, IoT, automation and robotics, cloud computing, cybersecurity, human-machine interfaces, and additive manufacturing. Big data helps process and analyze large sets of information, while IoT connects all components of a system for real-time data exchange. Automation and robotics enhance process efficiency and flexibility. Cloud computing enables data storage and accessibility across networks, supported by cybersecurity for data protection. Human-machine interfaces enhance interaction and control, while additive manufacturing, such as 3D printing, accelerates production and customization. These are the more detailed definitions of enabling technologies. Starting from cloud computing, cybersecurity, Internet of Things, system integration, simulation, test the chemical and physical phenomena in a faster way, autonomous robots. As in Industry 3.0, the robots were not autonomous as they were programmed to perform the tasks and not take decisions by themselves. Big data, augmented reality, and additive manufacturing. These are the technologies that will enable industries to develop efficient new production processes. An advanced manufacturing solution is an interconnected and modular system designed to enhance flexibility and improve performance. These systems enable machine-to-machine communication, allowing the exchange of information between similar or different machines to improve the quality and efficiency of ongoing processes. Cobotic or collaborative robotics refers to robots that work alongside human operators, assisting them in performing tasks that typically require human interaction. Additive manufacturing is the addition of different production systems to enhance the efficiency of the materials in use. The best example of additive manufacturing is 3D printers. It will help to print the desired design in less time to gain suitable knowledge. Augmented reality guides operators to perform tasks in their daily activities. For example, machine maintenance has become much easier compared to the past, as proper layout is now designed, and any broken part can be easily identified, reported, and replaced efficiently. Nowadays, the quality of software simulation is very high, and we can also simulate very complex systems in multiple phases to analyze their chemical and physical properties. The example shows a sensor for medium voltage applications that helps to measure current and voltage. It is based on capacitance to make a voltage divider. The value of capacitance allows us to measure the voltage. In the past, with less powerful tools, many prototypes were developed to achieve the best results, but with the new simulation tool, it speeds up the process and develops objects. Digital twins are a particular simulation that requires modeling of a physical object in a simulation to replicate their behavior by changing their parameters. So it establishes a link between the physical and cyber world. It produced a good replica of a physical object to help in predictive maintenance. The concept of horizontal and vertical integration is crucial for modern production processes. Vertical integration ensures the seamless flow of information from all levels of production, such as from the sensors and devices on the shop floor, field control level, up to the enterprise resource planning, ERP systems, and the cloud. Horizontal integration enables the automatic sharing and exchange of information between different companies, partners, or value chain actors to improve efficiency across the entire production network. The goal of both is to create a single, unified, and highly efficient system by sharing information and combining distributed intelligence with centralized information hubs. Cloud computing, an essential element of Industry 4.0, which allows for online storage and accessible information. The cloud is vital for interconnecting systems across the manufacturing process to efficiently collect, share, and manage the massive amounts of data generated. It enables the use of external data analytic services and open systems, ensuring information is accessible from everywhere to boost efficiency. Big data analytics is also an essential management technique for handling the massive volumes of data stored in the cloud. It involves extracting useful, actionable information from these huge data sets, using advanced tools and open systems. The primary goal is to allow for predictions, enabling manufacturers to forecast trends and make data-driven decisions to optimize their processes. Industrial Internet is crucial for communication between all elements of production, both inside and outside the company. Using low-cost networks like Wi-Fi or LAN, the industrial IoT connects objects and devices, enabling smart sensors to send information and receive control commands. This continuous, persistent communication is fundamental to establishing interconnected and autonomous manufacturing systems. All the streams of information are stored in the cloud. They are really important for the processes. Cybersecurity addresses the vital need for information security and protecting operational systems. Its purpose is to ensure that the system remains safe from any intrusion and that control or data cannot be altered from the outside, thereby maintaining the integrity of the entire production process. This is a broad picture of the Industry 4.0 ecosystem. It involves all the processes, such as Logistic 4.0, concept of production, IT, AI, reduction of cost and increasing efficiency, from supplier to cloud computing, big data, advanced manufacturing system, robot, autonomous vehicle, and Internet of Things. Renewable resources are added under this to make it eco-friendly. Also, get clean energy and store excess energy from renewable resources. The industry gets incentives from the electricity operators to reduce its demand in peak hours. In modern industry, we can define two inputs for production. One is the raw material, and the second is data. If you want a good product that will require good raw material and information to make the production process more efficient, how good are the data you connected to make a better decision? We need good quality data to make a good decision. If you have bad data, it means a bad decision. The efficiency of the system is based on the quality of data, because systems nowadays are data-driven. All the decision in the production is based on information from data. On many occasions, this data is something that is measured from the system. The main problems faced with quality data are data collection, management of data, and evaluating the quality of data. Thank you for your attention. This video was produced through the collaboration of SS Cyril and Methodius University of Skopje, the University of Nice and Politecnico di Milano, within the framework of the European project Personalized Education in Measurement Science and Technology Empowered by Machine Learning. More information about the project can be found on the project website and LinkedIn page.